Let's see it. Okay, so how do you figure that one out? Well, they had the populations up there. You got to have the, don't you have to have, we got to find the standard divisor first, right? Standard divisor, what is that? That's the total population divided by the number of seats, isn't it? So the total population, you got to add all those up to get the total population. So I'm going to add those up. 250, 875, 4,700, 3,825, 350. Total. So the total population is what? 10,000? So if I added all these up, and I got 10,000. Right, so this stuff's on the test. Tuesday's our test, huh? Yeah, Tuesday is our test. So next time's our test. So there'll certainly be one of these on there. So you add them all up, total population is 10,000. The bottom, the number of seats is 250, they told us that. So if you divide 10,000 by 250, you get 40. What is that? That's the standard divisor. Standard divisor then is 40. And that means that's the thing you divide by. That's why it's called standard divisor, right? So you divide by 40. Divide what by 40? Each state by 40. So you divide A by 40, B by 40. Anyway, they're just asking about A. So I'll just do A, 25. Didn't they say A? Yeah, for A, state A. 6.25. That's the standard quota, meaning that's what A should fairly get. Out of the 250 seats in the legislature, A should get 6.25. That'd be exactly fair. Remember, the whole chapter was about, well, they can't get part of a representative. They're either going to get 6 or 7, and that's the rest of the story. Yeah?
It said population in the thousands, so we didn't add 2 more zeros?
Population. Oh, was it out of 1,000? Is that what it said?
Yes, I was adding more zeros than I had to.
Oh, yeah, it did say in thousands. You're right. It says, but we don't have to do anything about that. It says in thousands. You are right. Yeah, so that means that 250 means 250,000. Yeah, but we don't have to do that. I mean, you can if you want to. If you want to add 3 zeros, right, to each of these, because that'd be 250,000. If you wanted to, you could add 3 zeros to all those, add all those up, and the real population would be 10 million, it turns out, actually. Divide by this, you'll get 40. I'm going to show you all this to say it doesn't matter in the end. Okay. You'd get 40,000 there, and then when you divided 250,000 by 40,000, the 3 zeros will cancel out, and you get the same answer in the end anyway. So you can skip the whole thing. Yeah, so you don't have to. When they say in thousands or in whatever, you can just skip it all. I mean, you can put it on too if you want to do all them zeros. In the end, they'll cancel out. Yeah, so you can just skip it. Is that good? Remember all that? Be able to do that on Tuesday when it counts for the big points. Right? The exams determine grades in here, right? Remember, look at that syllabus. I'm not trying to be secretive about that. I'm trying to be upfront and honest and straight ahead so you know what it takes to pass, which is, I assume, your goal. To do well in those exams, right? Do well in those exams. Almost all the points are on exams. 100 points per exam. Homework, all the homework's only 50 points. So it's not about the homework. Even the quizzes are 50. So the quizzes and homework together, I guess, are one exam. So that's a little bit of weight. So all the quizzes and all the homework put together, they're 50, 50, 100. So they're equal to one exam. But we have 6 exams. So it's all about mastering those exams. All right. On that note, we better look at that practice, right? We were doing that last time. So I want to spend maybe 40 minutes. I got an hour left. And then I want to start chapter 6. I do need to start new stuff a little bit, but let's do a good job finishing up the practice exam. So this is practice exam number 2 that we began last time, right? You guys took it in here. I gave it back to you, and now we're going to crank through it. If you didn't get it last time, I have some extra copies. They're also online, so you can do that. So there they are if you want them. The answers are online too. Yeah. So you guys know what I mean by online? Does everybody know where they're at? Let me do that real quick. All right. There we go. So this practice exam 2. Let's keep cranking. So we did number 7 last time. Whoops, I just miscircled it. Number 7, and they told us which player's the divider, and that was the D because all the numbers are the same, right? Whichever player has all the numbers the same is always the divider. Now they're going to say, assuming he plays honestly, what should player C declare? Now, how are we going to figure that out? Well, we've got to get totals on these guys, right? We got to get totals. So let's go through. If you add up all the numbers, across like this and get the total for A, total for B, etc. 7, 10, 15 here? This person, 7, 8, 15, 20, $20. I just added those up. Use your calculator, whatever. 2, 350, 4, 5, $5. And this person, 3, 5, 10. And this person, 4, 5, 6, 10. All right, so I just added those up sideways. And we need to know what a fair share is. How do you figure out a fair share? You take the total. Like if you and a bunch of friends found a pot of money, found a treasure, how would you divide it up fairly? You take the whole amount and divide by how many people there are, right? That's what we consider fair. Divide by the number of people in your group, right? So that's always how we do fair share in this chapter. We take the total and we divide by the number of people. How many people in this problem? 5 people. A, B, C, D, E, right? 5 people. So divide each of these by 5 to find out what is fair for these various players. Is this problem making any sense? This is this means that player A thinks share one. I don't even know what they're sharing. What is it, a cake or something like that? They think slice 1 of the cake is only worth $1. Player A does. Player A thinks slice 2 is worth $4. Slice 3, player A thinks is worth $3. Slice 4 is worth 4, and slice 5 is worth 3. That's how player A feels about the various slices of cake. If somebody took cake. In fact, D cut the cake, right? D cut the cake, took some big old cake, cut it into 5 different pieces, and then each player says what they think the pieces are worth to them monetarily. Player A says what he says, and on you go. So then if you take the total of everything player A says all the pieces are worth, player A is basically saying the cake's worth $15. I added up all those pieces, got $15. Divide by 5, I get 3. So that's a fair share to player A. You see how I did that? Because player A, if you add up all player A's numbers, $15 the total value of the cake, divided by 5 people, player A is saying anything worth $3 or more is a fair share in his mind. Right? So I came up with that. Total value to A, $15 divided by 5 people, $3 for a fair share. And on you go. And so I'm supposed to do it for C. So I'll come on down and I'll just do all the rest. 25 divided, this would be 4, this would be 1, this would be 2 and 2. So for player C, $1, anything worth $1 or more is a fair share. Because player C thinks the whole cake's only worth $5. Divided by 5 people, he thinks $1 a fair share in his financial world. So he would think $1.25 slice 1 is fair to player C. Not slice 2 or not slice 3. They're worth less than $1, he thinks. Not slice 4, and then slice 5 is worth $1.50. So player C thinks that slice 1 or slice 5 are fair shares in his mind. See how I figured that out? Add them all up, divided by 5, anything $1 or more for player C, he thinks is fair. So his declaration, when it says down here, what's his declaration? He's going to declare which pieces he thinks are fair. And that'd be S1 and S5. Answer A. We good? Question 9. Which of the following is a fair division? So for that, we got to circle all the fair shares throughout the problem. So let me do that. I'm going to go and start circling fair shares. So for player A, anything $3 or more. That'd be this one, this one, this one, and that one. For player B, anything $4 or more. This one, this one. For player D, anything $2 or more. This one, all of them. Yeah, because he's a divider. He thinks they're all fair. He cut them. And then player E, $2 or more. This one and that one. Okay, so all those are fair ones in those people's minds. So here comes the question. What's a fair division of the cake? Well, let's try it out. I'm just going to go through, try them out. A gets S4. Is that fair? Does A want S4? Yeah, that's fair. B gets S2. Is that fair? Yeah, B likes S2. C gets S1. Yeah. D gets S3. Yeah. E gets S5. Yeah, that's fair. A's fair. Are none of the other? Let's try B. Maybe they're all fair. Let's try B. A gets S4. Yeah. B gets S5. Yeah. C gets S1. Yeah. D gets S3. Yeah. E gets S2. Yeah. Oh, I've got 2 of them that are already fair, so they must all be fair. Does that make sense? You can try the third one if you want to be sure. A gets S3. Yeah. B gets S2. Yeah, that's circled right here. C gets S1. Yeah, that's circled right here. D gets S4. Yeah, that's circled right here. And E gets S5. Yep, that's circled right there. A, B, and C are all fair. All of these are fair divisions. D. Make sense? Onward we go. Questions? Okay, so be the way it is on Tuesday. 10's got some tricks. Joe and Bill want to divide a cake using the divider chooser, right? That's where one cuts it, the other one picks. So they draw straws. It's determined that Bill will be the divider. Bill's going to cut it, and Joe's the chooser. So Bill, let me be clear on this. Whoops. Bill is the divider, and Joe's the chooser. Right? Bill cuts the cake, and Joe picks first, in other words. All right. Assuming that each plays the game correctly, which of the following cannot, did you notice that? It doesn't say can be true, it says cannot be true. That's tricky. Bill believes that his share is worth 60% of the cake.
Stop right there.
What's that?
You can stop right there, right?
Good job. Exactly. Does everybody see that? He's right on the money. Why? Why can that not be true? He's the cutter. What does the cutter do? He cuts it fair because he gets last pick. Like I always say, you should see it with kids. It's serious business, right? And my Johnny boy with his little sister watching the cookie, he becomes a surgeon, right? He will finish that baby fair because he knows he gets last pick. So if Bill's the cutter, when he's done cutting, he won't cut so that he has a piece that's more than 50%. He won't, because he's afraid that Joe would have chosen that piece. So when he's done cutting, he'll cut that cake 50-50 in his opinion, anyway. Make sense? So yeah, it's A, right off the bat, A. So can we just move on? Good job on it. And be careful. All right, let's go through. So just a lot of steps here. What's the next step? We have to do the total. So let's go through and write the total. So let me see, 240, 256. Add these up, 262, 190, 208, 248, and I can't do that one. Thank you. 250. All right, and then you want to do fair share underneath it. So you have a whole table. Go ahead and put this on your 3x5 card. Put one whole example. You get a 3x5 card Tuesday. Put a whole example of one of these. Right on your card. Probably a good idea. Probably one of the major things you want to put on your card. All right, now fair. How do you do fair share? What do you always divide by for fair share? Number of people, huh? How many people? 4 people, yeah. So don't get confused by the number of objects, 3 objects, but 4 people, exactly right. So divide each of those by 4. So what's that, 64? 240, yeah. And then, I don't know, I need a calculator. Thank you. 65,500. And then 124. Was it 62?
Yeah.
Thank you. 25, 62.5?
Yeah.
62.5. So there's a fair share for each of those people. I just divided the total numbers by 4. Okay, now that we got fair share, we got to give away the objects. So who gets, let's start with the house. Who gets the house? Remember, so you look at how they bid on the house, and whoever bid highest on the house gets it. B, right? B gets the house because he bid the highest. All right, next, who gets the cabin? A bid highest in the cabin. A gets the cabin. By the way, notice I'm not even looking at the questions yet. Have you noticed? I'm just going to crank through the process. Then the questions will be easy once I've got the whole thing laid out. Boat. Who gets the boat? C bid the highest on the boat, right? 18,000. All right. So there's the objects. They're all going to get money or pay money to make everything equal out. Remember how this works? You pay money or get money, and everything equals out in the end. So everybody gets a fair share. Okay. So now there's the, what do you call it? The pay get. Is that what I said? Pay get? Next column. Pay get. Is that what I said? Pay get? Yeah. I call it different things every semester. I think I call it pay get. Yeah. So, and how do you do the pay get? That one's tricky. It's object minus fair. Isn't that the way I wrote it? Object minus fare. So the pay get is object minus fare. So for the person A, for example, you take the object they got, the $60,000 cabin, minus the fair share, 64,000, that comes out minus 4,000. Remember that? Now what does that minus 4,000 mean? Negative equals they're going to get something. Positive, which it's kind of backwards how you might think of it, huh? It's so that the surplus is easy to calculate at the end. That's why I do it this way, so that it's easy to do the surplus. We'll just add them up and we'll have the surplus real simple. Just to make that. So negative actually means stuff you get. Positive is stuff you pay. And that makes sense, doesn't it? Because person A, a fair share to them is $64,000, right? Because they added up everything. They thought all the stuff together was with $256,000. Divide that by 4 people. Therefore, person A thinks as long as he gets $64,000 worth of stuff, he's been given a fair share. Well, you give him the cabin, that's $60,000. So he still has 4,000 more coming to get a fair share. That's what the negative 4,000 means. He's going to get. So he's going to get the cabin, which he believes is worth 60, and he's going to get $4,000 out of the estate. Then he'll be thinking he got a fair deal, right? Give him the cabin and 4,000. He'll go, yeah. That's $64,000 worth of stuff. That's a fair share in my mind. All right, and then the next person. Take the object minus the fair share. So, I don't know, 200 minus 5. I'm getting 134.5. Positive 134.5, which means that person's going to have to pay. So this person's going to have to pay $134,500 into the estate. Why? Because they got something too valuable. They were given a house, which they thought was worth way more than their fair share, so they got to pay some money back into the estate. Person C, object, boat, minus fair share, 18 minus 62. I'm getting, what, negative 44? Again, that's a get. They get, why? Because they got something not worth very much. They just got the boat, which is only 18. They need some cash with that, 44,000. Then they feel they got a fair deal. This okay? What about person D? Yeah, no object at all. So it's always object minus fair. So nothing minus their fair share, 62.5. So it's just minus 62.5. They just get. Remember, negatives get. They just get the whole 62,500 in cash. We just hand it to them. Right? Because they got no objects. So we just give them their whole, what they think is a fair deal, just hand them $62,500 out of the estate. All right, that's the pay get. And now, below that, and then we got to calculate the surplus. How do you do the surplus? You just add up, just take your calculator, minus 4,000 plus 134,500 minus 44,000 minus 62,500. Just simply on, that's why I did the signs that way, to make that easy to do the surplus. That's like the extra money that'll be left over, the surplus. So minus 4,000 plus 134.5 minus 44,000 minus 62,500. Somebody got that? No? Okay, I can do it. Yeah, right. Positive 24,000. That's the surplus. That's the extra money left over after everybody pays in and gets out. Why is there extra? There'll always be extra because this person paid a whole bunch, right? It's because we're giving the objects to the highest bidders, so there'll always be extra money in there. So there's an extra $24,000. What are we going to do with that extra $24,000?
Divide by 4 and give it back.
Yeah, divide by 4 and give them extra. So we take that 24,000 now, and they get the extra or final. You call it the final allotment. Final, they get an extra. Add to everybody. It's money they're getting. So what should I really do with that? Well, I don't want to confuse you here. Take 24,000, and you divide it. Is it on the screen down there? Yeah. Let me just put it down. Whoop, come on. Divide it by 4. 4 people, yeah. 4. So it's 6,000 per person, isn't it? 6,000 per person. So they each get an extra 6,000. So this person gets 4,000, add 6 to that. They're getting 10. If you want, you could just go subtract 6,000 because remember, it's money they get. And getting is negative. It's negative out of the estate is what that means. Negative, just subtract 6,000. Just go negative 6,000 with each of these. And you'll get the final allotments. So the 134.5 person, 134.5, they end up having to pay 128.5. So it lowers the amount they pay. This person, it's minus, they get 50,000 back. And this person is something, 68,500 they get. There's the final story. That's the end of the story, the final extra. Everybody understand that last step? Was that a little confusing? Let me go over it one more time. So the surplus, everybody get that written down? So the surplus came from just adding up these pay-get numbers, right? Positives and negatives, the surplus, just add them up. Got the 24,000, that's the extra leftover money in the pot. Divide by 4, because there's 4 people. That means each person gets an extra $6,000. So then you say, okay, person A, you're getting 4,000. Now, if the signs confuse you at this point, just go ahead and ignore them if they're bugging you. Just say, look, they're getting 4,000. They're going to get an extra 6. That's 10. They're getting 10,000. The person B is paying 134.5. So when we give them an extra 6, that'll just lower the amount they need to pay. That's why I subtracted there. Does that make sense? They're paying a whole bunch of money, 134,500, but we're going to give them back 6,000 out of the surplus pot. So really, it just means in the end they're paying less money total. That's subtracting. The other people are getting 44,000. Add 6 to that's 50. 62,500. Add 6 to that, $68,500. So there's the final allotments. Now, from that, we should be able to answer any question they want to ask us. Let's go see. Questions on that calculation?
So you're getting the 6,000 and you're to do the extra part to each. You're getting the 6,000 and subtracting it from the pay get.
Yeah. So the reason is because negative amounts are money you get.
Right.
So that's the trick. You got to keep remembering negatives are when people get something. Because what it is, it's negative out of the estate. So when somebody gets something, it's a negative to the estate. The estate pays them out. So because this is get money, the 6,000, it's negative really. So I put negative 6,000 on all of them.
But there were.
That makes sense? Because it's get. And then when you add 2 negatives,
I'll come back to
it's a big negative on that. Sure. Other questions I can answer? Yeah.
On number 12.
Okay, so here's all the calculations. I'm just going to go back and forth. So here's the questions. Number 11. The original. So that's it first, right? Original fair share player B. Let's go back. Fair share player B. Fair share player B. There it is. 65,500. Fair share player B. 65,500. We good? That's a fair share for player B. So 65,500. There it is. Question 12. In the initial, what does initial mean? At first, not the final. For player B, what does player B get at first? So that means what does player B get at first? Player B gets the house and has to pay 134,500 at first, right? Now the final, really, we give him 6,000 of that back because of the extra money in the pot, the surplus. But at first, that's what they mean initially. At first, player B pays 134,500 and gets the house, right? Let's see that. Gets the house, and there it is. C. Gets the house and pays the estate 134,500 initially. Number 13. Is that good so far? Number 13. After the initial allocation to each player, the surplus there is a surplus of, that's the 24,000. And then 14, after all is said and done, the final allocation to B. What does B get after all is said and done? After all is said and done, B has to pay, this is pay because it's positive, 128.5 because we gave him back 6,000. So 128.5, there it is, answer A. The house minus 128,500 cash. They got to pay. He's got to pay that back. That's the final story because we gave him 6,000 back. Is that good? Look, you can do that on Tuesday when it counts for the big points. So practice that. Make sure you can calculate all that. And is that okay? All right. Okay. So here we go. Method of markers. So I would suggest that you put the numbers. You don't have to, but I found it's easier for students. So I'm going to start with the A, and I'm going to go A1, A2, A3. A1, 2, and 3. I just started on the left. First A, second A, third A. And then I'll do B. First B, second B, third B. Then I'll do C. First C, second C, third C. Then I'll do D. First D, second D, third D. Just to keep it, well, I guess it came out pretty obvious. Anyway, here we go. Actually, before you even do any of the questions, you should just do the whole method, right? Let's just do the entire method, figure out where all the stuff is, and the questions will be easy. So how do we do the method of markers? So you do the first number 1 marker on the left. So starting on the left, what's the first number 1 marker? A1. And then you go left. A gets, that's what A gets, is candy 1. Then you take the first number 2 marker. Now, one thing though is you have to take A out of the problem now. A's gone, A's gone, A's gone. Because A's already got his allotment, and we're on to the other players. So A's out of the problem. A was given his allotment, his piece of candy. Now, what's the first number 2 marker? We're supposed to find the first. So we found the first number 1 marker. That was A1. What's first number 2 marker? Yeah, D2. Right there, D2. See, we might have thought A2, but A's out of the problem. So that's an easy place to mess up. So D2 now. How far left do I go? Do I go all the way back to 1? Here's the mistake I've seen students make a lot. Most students get the hang of the first marker, second marker, they're no problem. But here's what they'll do. That'll mess them up. They'll go, okay, it's all the way back like that. That's wrong. If you do that, it'll mess you up. It's not true. It's wrong. Why not? What's wrong with that?
You don't get 2.
Yeah. Remember, you're only supposed to go back to the other D marker. D put markers between there and there. That's all he gets. You don't go into somebody else's territory, right? So the D will stop right there. Why? Because D put a marker there. That was D's fault. D did it. D could have put that marker wherever he wanted, right? You see that? You see how I'm going between 2 D markers? You're always going between 2 whatever markers, right? People only get stuff they've marked off. A to A, B to B, C to C, D to D. That's all they get. You don't go past it. So you only go down to their other previous marker. So that's a D section. D marked out that section by putting markers there. So that's what D gets. Well, then what about candy 2? Leftover. Remember how we're going to have leftovers? Surplus, so to speak. Good so far? Remember all this?
So which one did D2 end up taking?
So D gets 3, 4, 5, 6, and 7.
Because you go back to D's previous marker, D1.
Right, right, exactly, because you go back to D's previous marker. Exactly. You always go back to their previous marker, not past it. That's the common mistake I've seen. I think if you get that straight, you'll be good. That's the only mistake I've seen over the years. People go too far on the markers. Okay, next one. So we did the first number 1, first number 2, first number 3. Oh, and get the D's out now, right? So cross out D everywhere. D's done. D's got their candy. First number 2 marker, go left to the other marker. You always go to their other marker. Same thing with first number 3 marker. Go left to their, yeah, I should say, to their other marker. Go left to their other marker. So, okay, what's the first number 3 marker? Yeah, C3. How far left? Until I hit another C marker. Right there at 10. That's going to be the C section. See how that's between two C markers? That was the first number 3 marker. And then the last one's easy. Who do you got left? All you got left is easy. The last, you go right though. That is the one thing that's different. On the last one, you do go right to the end. And that's who's left? We got A, D, and C. We got B. So just like that. Right? Just from where? Because B is all the only one left. So go B to the end. So I don't get candy 15. That's a leftover. Candy 15 is left over. It's B to the end. B was the last marker. So that's B's mark. Does that make sense? Now we can answer all the questions. Right? Those are all sections they marked out. They should feel we gave them a fair deal. That's the name of this chapter, right? Fair division. So they put the markers where they thought things were fair. They all got sections they themselves marked out as fair on that. Yeah?
Sorry, I missed what you said. So the last one that's left is B, so you go to the very last B?
Yeah. So all the rest go left. But the very last one, you go right to the end. Yeah, so right where B is, yeah, to the last B, I see what you're saying. Yeah, last B and then go to the end. Exactly. Yeah. Good, okay, so now we can answer all the questions. So item 8, where's item 8? Oh, it's leftover. Item 9, it's leftover. This is like a trick question. Item 15, leftover. Those are all E, aren't they? Did they trick you? Leftover, leftover, leftover. Good? Questions on that? All right, let's do that. Okay, so I'm just going to write them down here if I can. So we have the states. We have what, A, B, C, and D? Okay, A, B, C, and D. Population, so we have A, B, C, and D. The population for these states, 67,200, 78.3. C is 73.8. D is 80,700. And then we're going to go through and do the quotas. Okay, there's a number of seats is 100. 100 seats. 100 seats. Okay, let's go over here and figure out the standard divisor. What's the standard divisor? You have the formula on your 3x5 card, right? Total population divided by number of seats. Total population. So we got to add up population. So I'm going to go over here and add them up. 67,200, 78,300, 73,800, 80,700. Add all those up.
You'll get 300,000.
Those, yeah, thank you. 300,000. So that's the total population. So bring it over here, 300,000 divided by number of seats, which is 100. That just cuts off 2 zeros. So standard divisor is 3,000. So the standard divisor is 3,000. So that means that's what we divide them all by. We go back and we divide by 3,000. Divide by 3,000. Divide by 3,000. Divide by 3,000. And we get what's called the standard quota, like their quote, what they should get to be truly fair. So let's go through and do that. Oops. Now I'm getting 22.4 for A. I'm getting 26.1 for B. 24.6 for C. And 26.9 for D. That's the standard quota. That's what they should really get completely fair. So here we go. So standard divisor, 3,000. We just calculated it right here. Next question. Standard quota for state C, 24.6 is the C right there. And coming on down here, number 20, under Hamilton. Now we're going to do Hamilton. We're going to do all four methods. Hamilton, Jefferson, Adams, and Webster's. So under Hamilton. All right. So do you remember how do we do Hamilton? Remember what we do for Mr. Hamilton?
Round down and
Round.
aside.
Yep, Hamilton, round down. So Hamilton round down. So 22.4 goes down to 22. 26.1 down to 26. 24.6, even that one rounds down. Even 26.9 rounds down. So down means down. We don't mean round off. Everybody catch the difference in this chapter. Round down means down, round up means up, and rounds off is what we're used to, where 0.5 goes up. That's what Webster does, huh? All right, so Hamilton rounds them all down, and then you add them up. You get over here and you get the total. So if you just add these up, is it like 98? I think it's 98. Yeah, 98. If you add those up sideways, that's 98 seats. How many are we really supposed to give away? 100. There's 100 seats actually, not 98. So we have 2 more seats to give away.
Don't you add it to the highest decimal?
Give it to the highest, right? Give those 2 extra seats to the 2 highest decimals. That's right. So come on in here and say, all right, which decimals are the highest? 0.9 and 0.6. That's what Hamilton does. Pretty simple, huh? Sure seems easy compared to the other fancier methods. Just give it to the 2 highest decimals. So let's do that. So let's come in and go, okay, 0.9 gets an extra seat, 0.6 gets an extra seat. So 25 there, 27 there, the other ones stay as they were. And that's 100 seats. And that's the, what's it called, the allocation for Hamilton's method. State A gets 22, B gets 26, C gets 25, D gets 27. So which answer's that? No, it's A. There it is under Hamilton's method. There we go. Good so far. So that's Hamilton's method. That's the nice one. Now we got to do the bad ones. So now we got to do Jefferson. So if you've got that copy down, I'm going to erase and do the do the Jefferson thing. So remember for Jefferson, I'll write some notes down here. For Jefferson, Jefferson's the downer, right? You pick a lower standard divisor and round down, down. Lower divisor, round down. Adams will do the opposite. He's higher divisor, round up. Right, up. Jefferson's down, right? Webster says, hey, just round off. Those are the other 3 methods. Jefferson is down, Adams is up, Webster is just round off. So this is actual Thomas Jefferson from history. This was a method used for a while. So pick a lower standard divisor and round all of them down. Why didn't we just stick with Hamilton's method in history? Why not? I mean, it's so simple.
Alabama paradox.
Good job. Good answer. Alabama paradox. Remember that weird thing happened with Alabama? There's a couple other weird things which I'm going to show you about in a couple minutes here as well. Yeah, a couple bad things. Remember the Alabama thing where it was going to steal seats from Alabama just because a new state joined the Union? Or no, because they added seats to the House of Representatives. It was going to steal states from Alabama. It did seem kind of unfair. So because of that unfairness, that's a lot of what this class is about, huh? Different ways of dividing things up and whatever, but some things seem unfair, so we have other math methods. All right. Because of that, because of the unfairness of Hamilton's method, these other methods came about. So Jefferson's method, what are we supposed to do? I'm supposed to go back and instead of dividing by 3,000, which is the standard divisor, you're supposed to divide by a number a little bit lower than 3,000. Something a little lower than 3,000. Well, that's erase all this. I don't want to do it part by part. Just erase it all. All right. So I got to divide by a number lower than what? How much lower? Who knows? How about 29,000? I'll just try that. No, wait. No. I'm being crazy here. 2,900, huh? 3,000 was the original. So I'm going to try. I'm just going down by 100. I don't know what's going to work. I'm just sort of guessing, and we'll see. So the standard divisor, remember, is 3,000. So 2,900 is a little lower. So what am I going to do? I'm going to divide all those populations now by the 2,900 and round all the answers down. So I get 23.17, or I'll just say, yeah, 23.1 or 2 or whatever. Who cares? Round it down. 78,300 divided by 900. I'm getting 27, right in the money. That's funny. 3,800 divided by 2,900. I'm getting 25.4. And 8,700 divided by, I'm getting 27.8. Round them all down. So down, says Jefferson, down, 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 down. 23, this just stays 27, it's not even a decimal. 25, 27. And then add them up. Is the total 100? No, it's like 102, isn't it? 52 and, yeah, it's 102. It came out too much. Are you with me? Am I losing you? So I divided, remember the original standard divisor was 3,000. So I lowered it a little bit because that's Jefferson's method, lower it. 2,900, divide it through by 2,900 and round them all down, not off, but all down, and add them up. The seats, you got to keep fiddling with this till the seats come out right. Came out 102, it's too big. It's too many seats. We only have 100 seats. So I got to change my 2,900, it's not working. I need to either go a little higher or a little lower. And here's the trick. Do you know which one? If you don't, you'll waste your life fiddling with this. Do I go higher or lower?
Higher.
Good, higher, higher. Remember, when it's too high, when it's great, 100, 102 is too high. Go higher. Now that sounds backwards, doesn't it? It's too high, you need to go lower. What I mean is your standard, your divisor needs to go higher because you're dividing by it. If you divide by a bigger number, it makes numbers smaller, right? So if this is too high and you need to bring it down, you got to divide by more. So remember that's important to know for all three methods other than Hamilton. We don't mess with this with Hamilton. But for Jefferson, Adams, and Webster, in all three of those methods, you're going to have to play this game of dividing, higher and lower numbers. So you really need to know that. Absolutely crucial. If it's too high, go higher. If it had come out something like 98, too low, I would have gone lower on my divisor. So I'm going to take my 2,900 divisor, and I'm going to go, all right, it's coming out too high, so I need to redo it, and this time I'm going to go higher. Now, how much higher? Never higher than the original 3,000. Are you with me? That's the original. Jefferson is always lower than the standard. Always lower than the original. You'll never go above the original with Jefferson. So I'm not going to go above 3,000. Everybody tracking with me? I'm just going to go higher than 2,900. So how about 2,950? 2,950 is a little higher than 2,900, but it's still under the 3,000. So that's a good choice. So divide by 2,950. So redo this and divide all these numbers this time by 2,950. So here we go again. Oh, I blew it. So I'm getting 22.8. And the next one.
26.5.
Yeah, 26.5. That's going to run. Have you noticed these two are both going to round down? We lost 2 right there. That's perfect. I don't want to lose any more. Hope I don't. 25.1. Oh, good. That barely stayed. So as long as this last one's good, we've got a winner. As long as he doesn't lower. I don't want him to lower. 27.3. Good. Perfect. That's going to work. See, if I lower all these numbers, see right there I lost 1. 22 is lower than 23 by 1. Round it down, right? Round down. And here, lowered round the 2060, that's lower than 27. I lost. Remember, I needed to lose 2, didn't I? There's the 2. The next one, 25.01, he rounds down to 25, same as the last time. Beautiful. I don't want to lose any more. 27.3 rounds down to 27, same as the last time. Beautiful. That's 100. I lost my 2 exactly. That's 100 seats. That's perfect. That's the answer. That's the allotment, or what do they call it? The apportionment for Jefferson's method. So which answer is it? 22, 26, 25, 27. Looks like it's D. Answer D down there for Jefferson's method. Are we good, Jefferson? Can I move on to Adams? Are we happy with that? Adams is going to be the same thing, just go higher. Adams is up and up, right? Adams thought, hey, this is no good. Jefferson's method's rounding everybody down. He says people don't want to be rounded down. The states want to be rounded up. So Jefferson said, pick a lower standard divisor instead of a higher one. No, wait, backwards. Pick a higher one instead of lower, right? Jefferson said pick low. Adams is going to say pick high. Pick something over 3,000, like 3,100 or something. Pick something higher. That's what Adams is going to do. So let's do that. I can just erase. If you guys got that copy down, I'm just going to erase this. So Adams is just the opposite from Jefferson. So come up here, and instead, so now. So now we're talking Adams, and he says pick a higher divisor, pick higher than standard, and round up. Okay, so 3,000 is our standard. Pick something higher, like 3,100. Maybe I should just go for 3,050. I don't know. I'll just try 3,100. So divide them all now, all these numbers, by 3,100. Round them all down and add them up. Here we go. I'm getting 21.6. Whoops. 0.6. These methods are tedious. 25.2. 23.8 and 8,700 divided by, bless you, 26.03. Okay, round, and they want round up. Round up. That's Jefferson said round them all. Adams said round them all up. So that'd be 22, 26. Even the 25.2 goes up. Everything goes up. 24, and even 26.03 goes up to 27. And that's, I don't know, what is that? 99, we're close. That's 99 seats. We're supposed to get 100. So we're too low. We're too low. What does that mean? Too low, go lower. Remember, it's counterintuitive. Too low, go lower. Too high, go higher. So I need to go lower. That standard deviation the divisor needs to go lower. That's too low. 99 is not 100. It's too low. Go lower. So remember how that works. If it's too high, you go higher. If it's too low, you go lower. So instead of 3,100, I got to go lower 3,050. I probably should have tried 3,050 to begin with. So and when I say lower, I don't mean below 3,000. It's going to be something over the original. That's Adams' method. It's going to be higher than the original, but lower than 3,100. So 3,050. So I'm going to go back, do 3,050. Should have done it to begin with. Hopefully that'll work, and I won't have to come back up again. So let's go back, divide them all by 3,050.
You get 22.
22.03. Yeah, good. You got all the answers?
Yeah.
What's the next one?
25.6.
Uh-huh.
And then 24.1.
Uh-huh.
And 26.4.
And then round them all up. So 23, 26, 25, 27. Oh, it's 101, isn't it? Looks like 101 to me. Yeah. It's too high. It's too high. This is coming out too high. Yeah. It's too high. It's over 100. So too high, go higher. So it's higher than 3,050, but we already know it's lower than 3,100. So what's between $3,050 and $3,100? $3,075. See, this just gets terrible, doesn't it? So now I got to go back and say, all right. Let me try 3075. See if that works. This is a bad one. So, all right, 67200 by 3075, 21.8, 78,300 divided by 3075, 25.4, 73,800 divided by 3075, 24, right on the money. 80,700 divided by 3075, 26.2. Round up, all up, 22, 26, 24 was straight on. He doesn't go anywhere. 27. No, it's too low. It's 99.
I think it was the last one, right? No.
What's that?
I think it was the last one, wasn't it?
The last one worked?
Yeah, I think so.
Not the numbers I was given.
No?
Well,
The first one was 21.9. That's
yeah,
what
I don't remember. It's off the screen now, but did not, is that what I had up or did not?
But you had 22 already, then I rounded like to 23, I think.
Did I? Is that what
I
happened?
think so, because I just did it right now and I got, well, my first answer, because I divided the 67 divided by 3050, I got 21.9 for the first one. And then I just did it all over again. I added them up, and because, like, you know how you have to round to the,
So you think the last one worked and we just made a small mistake?
yeah, I think so.
Okay, let me try.
I think so.
Let's see. So what was it, 3050?
Yeah.
So 67200 divided by 3050, which is it's 22.03. Is that what you got?
Which one? No, my calculator gave me something else. It gave me
Want to try it again?
21.9.
So you're doing 67,200 divided by 3050, right?
Uh-huh.
Okay. So see how you don't have the 200?
Oh.
So, okay, so 99 is coming out too low.
Oh, I answered wrong. My bad, sorry.
That's okay. No, it's easy. I know there's a million
Yeah,
numbers
yeah.
here. So 99's coming out too low. So this is a terrible and awful problem. It's too low. This is like torturous. I'm sure the one on the real exam is this or harder. No, I hopefully it's not. I don't remember what it said. Too low, go lower, right? That's too low, go low. So it's lower than what we just did, 3075? It's lower than 3075, but it's higher than 3050 because we already tried 3050. So what, like 3060? So somebody got this thing one told me, is it 3060? Does that work?
I'm gonna try 60.
Okay, let's try. I'm getting a little tired. I don't have all day here. You don't have all day. Let's go back and try 3060. This is just so touchy. So 3060, all right. Divided by 3060, 21.9, 78,300 divided by 3060, 25.6, 73,800 divided by 3060, 24.1, 8,700 divided by 3060, 26.3. Round them all up, 22, 26, 25, 27. There it is. Oh, yeah. There it is. All right, 100 seats. That was terrible. That was really, that's about as bad as I've ever seen it. So there's the answer for Adams and his horrible method. 22, 26, 25, 27. All right, so you can save these for last on the real test, right? These are terrible. All right, we still have to do Webster's after all that. We still have to do. So 3060 was the magic number that worked. We knew it had to be something between 3050 and 3075 by our warmer, colder, higher, lower stuff. All right, so we have got to try now. Now, Webster's easier. Webster. Let me show you Webster. Webster is not Adams and Jefferson are the bad ones. Let's do Webster. Okay, so for Webster, he's the rounder offer, right? He rounds off. So Webster, and you try the standard divisor first. You don't automatically go higher than 3,000 or lower than 3,000. Most of the time, the plain one works, and it will this time too. This will be easy. Try the standard divisor 3,000 first, and round all off, which means 0.5 up, 0.4 down. instead of rounding everybody up, round everybody down, Webster, which I totally agree with them, said, hey, why don't we just round them off instead of all up or all down? Adams and Jefferson are nuts with all this round up, round down stuff. Just try rounding them all off. And that. So I want to make this point clear, though, so you don't get messed up. You stick with the normal standard divisor with Webster's at first. Now, if it doesn't work, comes out too low, I'll go lower, too high, I'll go higher. I might have to still play that game, but almost always you don't. Almost always you don't. Usually if you just do the standard, it works right away on Webster's. Not always, but try that first. Whereas Adams and Jefferson, we go higher right away or lower right away. Don't we? We never even use 3,000. We never use the original for Jefferson or Adams. Everybody with me on that? Jefferson, it's always lower. Adams, it's always higher. You never use the original. Webster's, you go ahead and give the original a try, and it usually works right there. Because Webster is much nicer. All right, let's try it. So I'm going to do Webster, and then I'm going to round off. So I'm going to divide by 3,000, the standard. I don't even remember what the numbers, whatever the numbers were originally. 67,200 divided by 3,000. 22.4, you're going to get the same numbers we got at first with Hamilton, because you're doing the same original first step. 4.6 and 80.7. So 26.9. So there they are. Now, round off. So this is different. Hamilton rounded everybody down and gave back the extra seats to the highest decimals. Jefferson rounded everybody down. Adams everybody up. Webster says, hey, let's just round off. So 0.4, he goes down to 22. 0.1, he goes down to 26. 0.6, he rounds up to 25. 26.9, he rounds up to 27. Add them up, look at that, 100 seats. Beautiful. There's Webster. Webster comes out the same as Hamilton in this case. Same apportionment as Hamilton gave. So that's, I don't know what the question is at, 23, probably. Is that question 23?
They all came out the same.
Did they?
Yeah.
All exactly the same? That's funny. Like, what's the purpose of these methods, huh? They all came out exactly the same? They all came out 22, 26, 25, 27? Really? Okay. Well, that's not always going to happen, but that's fun. We good? All right. So these will be a valuable 7 minutes here. Okay, this I really haven't told you about because we kind of ran out of time and I wanted to keep moving. So you need to know this. So here we go. In a certain, the apportionment method, following methods could have produced this result. Yeah, I need to give you a table of facts. I don't think I've done that. Let me do that for you right now. Because I didn't really get into which methods can do which bad things. Yeah, let me show you that right now. Let me just go for a blank. Or did I? No, I don't think I did. So let me mention some different things that can happen. Now you remember the Alabama paradox, right? The Alabama paradox. That what happened with that is more seats were given to the United States as a whole, and somehow Alabama lost one. So that's just not right. If there's more seats being given to the whole United States, why would Alabama lose one in the calculation? That was the frustrating thing for Alabama. Hamilton's method did that. That's called the Alabama paradox. There's also something called the population paradox. Let me write. So this would be very good. This 3x5 card. This is heavy 3x5 card material. You want this on your 3x5 card for the exam on Tuesday. So population paradox. That one says, let me write it right here. Population.
State A loses a seat to B.
Yeah.
Even though population of A grew at a higher rate of B.
Good. Yeah. So one state loses, you can write it however you want. One state loses a seat to another state growing at a slower rate. So, year by year, they would redo the calculation and they would shift. California we've grown in population over the years. Now we have more population than any other state. Obviously, it didn't start out that way. So over the years, we've got more and more seats on the House of Representatives, right? Every year they redo the calculation. Well, something weird can happen where one state during the year, one state can actually lose a seat to another state who didn't grow as fast as them. Just how the numbers work out with Hamilton. These are all bad things that Hamilton's method can do. I'll write that all out in a minute. Finally, there's a third bad one, new states paradox. This is the third and the last. Well, then one other kind of thing is a little different. Adding a new state. You know how new states were joining the Union back when the United States was getting formed? Adding new state with its fair share. So what they would try to do when they added a new state to the Union is they would just calculate ahead of time, okay, this new state has whatever population, so they should get, 7 seats in the House of Reps. And they would just let the House of Representatives grow by however many seats that new state should get. Therefore, they didn't take any from anybody because they knew the states would get mad. So if they had a new state, they would calculate ahead of time, go, oh, he gets 7 seats, so boom, we'll make the House of Representatives go from 200 people to 207 now, or whatever. Well, it's not that simple. Sometimes you can add the new state with its fair share and other states lose seats. It can just happen because of the calculation. Other states lose seats. It's weird the way it works out. All these things are the bad things that Hamilton's method can do, and are all the reasons why Hamilton's method's not used. So if you got that down, let me go to a fresh screen. Let me give you actually one more thing. It's called the upper quota or low quota. So remember quota. Quota is exact fair share for a state. Exact fair share for a state. So let's say the quota for A, say it's 23.4 or whatever. So for example, suppose it's 23.4. The upper quota, like the most they should ever get, is rounded up, 24. The lower quota, the least they should ever get, upper quota 24, lower quota 23. You with me so far? So in all these different methods, remember what we're doing. We're calculating what the fair share of a state is. How much they should really get based on their population. Well, suppose some state comes out 23.4. Well, the most they should ever get, whatever method you want to use, Jefferson, Adams, Webster, whatever, is 24, right? They should never get, for example, 25 seats. But if they get 25, well, let me just change the color here. If they get, say, like 25 or more, that's what we call an upper quota violation. That's just not right. Right? I mean, they're supposed to get 23.4. Maybe you could round them up to 24 at most. But you don't give them more than 24. You don't give them 25 or more. That's just wrong. Whatever method you're using, that's just unfair. Make sense? We call that an upper quota, like rounding up, violation. It went above even rounding up. That's not fair. And if they get, the lowest they should get is 23, right? Because again, they really deserve 23 and a half about. So the lowest they should get is 23 if you round them down. If they get 22 or less, if they get below the bottom of fairness, that's just really not fair. That's a lower quota violation. That just should not be. They should not get 22 or less. That's a lower quota violation. Any method that does that is doing something bad. All right. We got all that written down. I'm going to go to a fresh screen and give you the summary of the story. So here's the quota violations. And here's the Alabama and the population and the new states. Okay, so, and I'll do the methods across the top here. So we're going to do Hamilton, Hamilton, Jefferson, Adams, and Webster. Hold on, I'll give you this information and we'll be out of here. So, last bit of information. So, Hamilton. No, he doesn't do any quota violations. Jefferson, upper. He can break upper quotas. Adams, he can break lower. Webster, he can break both, surprisingly. Alabama, yes. Population, yes. And new states, yes, for Hamilton. Hamilton can break all those things. Hamilton does bad things with Alabama, paradox, population, and new states. All the rest are no. The other methods do not do the Alabama, population, or new states. And then the final thing, they all have a favoritism. They bias. They have a bias. Hamilton biases large states. He gives large states a bonus. So does Jefferson. Small states for Adams. And the only one that's neutral, my favorite method, Webster's. What we actually use in the U.S. Senate today, or the Congress, I mean, is a method similar to Webster's. We ended up adopting one very similar to Webster's. It's called the, I can't remember right now. Anyway, last thing. There's a Belinsky-Young theorem, that says there's no fair method. It's been proven mathematically. It's kind of like the voting one. They've proven that no fair method exists. There is actually no way to get around one of these kind of biases. Every method has the potential to be biased in how it breaks up. But there's some that are better than others. So the method we use now is a similar version to Webster's. It's a little more complex. It's what we actually use. And they fixed the House of Representatives to 435. All right, so with that in mind, I think the questions will be easy. The other questions on there. You have the answers for all of them. So I'll leave you on that note. We're out of time, so we don't even have time for a clicker today. So I'm going to just stop there. Well, I can do it real quick. I want to give you guys points for being here. Hold on. Let me just fire it up. 2 seconds and you'll be out of here. And there. It's up. Click A for Apple, and you're out of here. A for Apple. You got your 10-point quiz. Thanks for hanging in there. It's over. Got questions? Feel free to hang out. Be glad to help you. Otherwise, I'll see you Tuesday for the test. I'll post this online right now.